Hi everyone. Let me give you a quick walkthrough of my AI-driven insurance claim processing. So it's an end-to-end architecture, automate claim submission and DQ validation, fraud detection with SageMaker, and store the data into Redshift and reporting all in real time. So the process begin when a user claim submit into SD bucket such as a PDF file. So we have the SD bucket named AICP claim data, and in this bucket we have several folders. So one of them folder named raw folder claim document where user will be submitted a claim as a PDF format. And then whenever claim will be submitted into SD bucket, we have a EventBridge role name AICP claim upload trigger, which is invoke AWS Lambda function called AICP claim processing trigger to start the workflow. After claim uploaded into SD bucket, we have AWS ECS called AICP ECS claim processor. Its job is to send the claim document to AWS TrackStack, which is run asynchronously to pull out all the important details like policy number, claimant information, damage description, literacy. So when TrackStack finish, it doesn't just sit there. It send a job complete notification into AWS SNS named AICP extract callback topics. The notification automatically trigger. We have another Lambda function that is called AICP TrackStack callback handler. So this Lambda function pick up the raw TrackStack output, clean and format it, and then save it finalized claim data into another SD folder named AICP claim data proceed claim extract data. So final clean data will be saved into this SD bucket folder. So the flow basically ECS forget start the TrackStack job, and then TrackStack run asynchronously to extract the claim data, and then SNS receive the job complete event directly from TrackStack, and then Lambda triggered by SNS clean and finalize the extract the data, and then store the clean structure claim data into this folder. AICP claim data as the bucket, and folder name is process, then claim extract data. The next we have AICP claim DQ job in AWS Glue. So data goes to the AWS data quality job. So in that job, we run several checks to make sure data is valid. For example, all the required field like claim ID and policy number actual present in the data set. So after validation, if fails, the record will be stored in the another SD folder name DQE fail data into AICP claim data SD bucket. And if validation pass, then the record will be stored in the another folder. Name is DQ validate claim data. After that, we have EventBridge role that is scheduled to run every 2 hours. So this role trigger the our Lambda function check AICP DQE, which is check the data quality validation into to this SD bucket every 2 hours, and then send an email notification to the AWS and SNS. So once validate completed, then we have the SageMaker endpoint powered by a custom Docker container. Name is AICP shape SageMaker container. So validated claim are sent to the real SageMaker endpoint. Inside the container, we use XGBoost model with shape explainability to score each claim and classify it as a auto approve, manual review, and suspicious. And the prediction output will be saved into another folder. Name is fraud predicted claim data into AICP claim data SD bucket. And then next we have another ECS named AICP fraud predictor load ECS. So it basically use to load the fraud prediction result from this SD bucket to AWS Redshift table name claim process table. And then we have the another table name claim DQE status. So this DQE status data will be stored from this to ST bucket DQE status. Have AWS QuickSet that connected to the Redshift to provide interactive dashboard, executive analysis, and that can monitor claims, fraud detection, performance, and data quality metrics in real time. So that was a quick walk through my AICP architecture. So now let me jump into AWS and quickly show you the services I use to build the AICP project. So let's go to the first ST bucket. So this is our ST bucket, AICP claim data. And in this bucket, we have the several folder. So this is the raw folder and claim documents where we will be submitting the claim. And then now next, go to the EventBridge role. So this is our EventBridge role, and it targeted with the ASAP claim processor trigger Lambda function. So here is the EventBridge role triggered with the Lambda function. And now let's go to the ECS. So this is our ASAP ECS cluster. In this cluster, let's go to the text definition and AICP ECS claim processor. So this is our AICP claim processing tags. And now let's go to the SNS. See the AICP extract callback topic. topics. So our topics name AICP extract callback topics. There you go. So AICP tracks. This is our topics name. AICP tracks the callback topics. And now let's go to see the Lambda function. Name is AICP tracks the callback handler. Here you go. So AICP tracks track callback handler. So here's the AICP tracks track callback handler. Trigger with that SNS. And here's the code. If you need the code, you will be finding all the code in my GitHub repo. And now next, go to the AWS Glue job to see the AICP claim decree job. So here is the Glue job, AICP claim decree job. Here all the code. You're gonna see the run status success. All of my run are success. And now let's go to the see the folder decree claim and decree validate claim data. Go to the SD bucket. Here's the SD bucket, ACP claim, and then this is the process folder. And here is the claim extract data. You see all the clean data saved into this SD folder, claim extract data. And then to see the validate data into this folder, DQE validate claim data. So all of the data file validate stored in this folder. And now next go to the architecture. So now let's go to the real time endpoint SageMaker. So we have the AICP shape SageMaker container. Let's go to the see the container. You see so here's the ECR. Here's the all container. ACP shape SageMaker container. And now let's see the real-time endpoint SageMaker. Go to the SageMaker. So now we have to go to the inference, and then let's see the endpoint. So this is our endpoint, AICP prod endpoint, and now see the endpoint configuration. So that is our configuration, and let's see the models. So this is our models, ACP SageMaker container. And now let's go to the architecture again. Oh, now let's see the ACP fraud predictor load ECS. Go to the ECS. There you go. So ACP fraud predictor load tags. Cluster and tags. You see these are the tags run and stop it. And now let's go to the architecture again. So now let's go to the Redshift to see that data is stored into the claim process table. So here is the table. We see that all the data is stored in that table with the claim status. Let's look at some claims directly from our Redshift table where we can see the claim level details. So here is one claim 15 fraud prediction not a fraud and fraud score 0. So which is was auto approve. If you see the claim status is the auto approve because of closely matches because of the claim amount closely matches the estimate damage and customer has no pure claims. So this profile the low risk profile. So if you see, so this customer has no previous claim, so that's why it is auto approve. And the second claim, fraud is scored 0, but fraud prediction not a fraud, but was flagged for manual review. If you see the claim status for manual review, it wasn't a fraud. The claim was, but the claim amount was higher than damage, and customer has the zero claims. That's why it was flagged for manual review. If you see, this customer has the previous claim 5. Now the third one is the 16. So fraud prediction is fraud, and fraud is score 9.8. So this claim was marked suspicious and classified as a fraud because only was the claim because of the claim amount was significantly higher than estimate damage, which is suspicious, and the accident location also in the high risk, which is for fraud, and also the claim has filed previous claim, which is signal higher risk. So let's see the this person has the previous 5 claims. That's why this claim was flagged by suspicious. So now let's go to the architecture. Now we have the quick site. Let's go to the quick site to see the AICP dashboard. This dashboard gives us a real-time insight into fraud detection and data quality and overall claim processing trends. So on the left, so here we see uh, claim distribution of insurance claim statuses. So the majority of claim are currently in manual review, and with a smaller portion auto approve, and very few flag as suspicious. And top right, AI fraud explanation types. So we have the AI generate fraud explanation types. So most of suspicious claims are flagged because the claim amount is significantly higher than estimate damage. On the other hand, claims where closely matches the estimate are classified as safe. So basically, this helps quickly understand why a claim was flagged. So now, the bottom left, we see the daily insurance claim submitted. So here we can track daily volume of claims submitted. So we can see the spike certain days. For example, August 22nd and 6th, we saw the highest claim submission. And the bottom right, data quality validation summary. So finally, this pie chart show the data quality check. So the vast majority of claim pass validation, but a small portion uh, failed due to missing or incorrect information. So this is a dashboard real time for detection and data quality check for AICP claim dashboard. So now let's go to the architecture. Okay. So, so this is the AI-driven insurance claim processing system. Take us into in from claim submission to the automated extraction and data quality validation and real-time fraud detection, all the way into Redshift report um, using QuickSight dashboard and also uh, PICP claim API and also chatbot access. So it delivery faster approval, reduce fraud, and more transparent claims experience built as a part of the ACP project. Thank you for watching the ACP project demo.